proti Pilsētas un nākamā industriālā revolūcija.
Cities and the next industrial revolution. Uz skatuves mēs aicinām Alastairu Parvinu, arhitektu, dizaineri, inovatīvās būvniecības platformas WikiHouse Foundation līdzdibinātāju, ar kuru kopā ieskatīsimies nākotnes pilsētu stratēģiskajā plānošanā. Alastair, please, welcome on board, welcome on stage.
Thank you very much. Good evening. I've got my people in. One of my heroes was an architect called Cedric Price, who famously said, technology is the answer, but what was the question? So what I want to talk about this evening for the next half hour is a really, really boring question, but a really, really important one, which is housing and cities, and what it means to apply technology to those things. Because Elon hasn't got round to it yet, basically. So the challenge that we face in this space is huge. Pretty much every country, developed economy in the world today has a housing crisis, but globally we also have this huge challenge in front of us. The rate of urbanization between now and 2050 means that we need to build a city the size of New York every 5 weeks for the next 33 years. And by the way, as if that wasn't hard enough, at the same time, we need to wean ourselves off fossil fuels to support a global population of 9.5 billion or thereabouts. This has never, ever been done, obviously. So it's a huge challenge. Not surprisingly, our current housing systems are failing. The way that we make cities it isn't even close to being able to address this challenge. And I don't just mean the technologies that we use to actually physically build our houses, although they are also quite obsolete. But I mean really the whole stack of the way that we invest in property and housing, the way that we plan our cities, and the way that we use our buildings and the way that we understand the way that they're used. The whole system hasn't really changed for about 200 years. And so this is an interesting graph. This is actually a graph. This is not a blank page. This is a graph, if you can see this on the screen. Now, this is a graph of who builds our homes. In this case, it's in the UK. And what it is, it's an extreme, what's called a long tail graph. That's to say, if you lined up everybody who built a home in a year on the x-axis and gave them a pixel each, and then on the y-axis you give them a pixel, which is how many they built. What it's showing is an extremely centralized industry. And in the UK, we have a very centralized industry in that almost half the homes we build are built by just 10 companies. But this is true in most developed economies. We have incredible dependence on a small number of big companies, these developers, who build our homes for us. We basically ignore what's called the long tail, the many small players. And this is really symptomatic. In a nutshell, this is the housing systems that we've all become used to, and we don't even notice them anymore. Right? This idea that the only way of building cities at scale is for development to be something done to people, not done by people. Because this was the assumption of the 20th century, was that the model on the right, the distributed model, simply isn't industrializable. It's not scalable, it's not regulatable, it's not investable. And so the result is this. This is not a cartoon. This is literally what we're building all around the world. We're familiar with this. Now that's where technology gets interesting, right? Because over the last decade or two, obviously we've entered the first stages of this radical digital revolution. And if we were going to generalize about what that revolution has done, and clearly I'm about to, it would be this. It would be that it's moved us from models like this, where production is done by a small number of big centralized players, to models where production is done by many small players. So that's Wikipedia is the world's biggest encyclopedia. YouTube is the world's most watched TV channel. Twitter, whether we like it or not, is the world's biggest journalism network. And of course, famously, Airbnb is the world's biggest hotel chain. And if you'd gone back even 10 years ago and said that that would be the case, they would say, no, it won't. It's too impossible. So technology, digitization is really good at scaling, at making the long tail scalable. All that's happening is that revolution is now coming to the world of physical things. So it's a series of technological shifts that we're all tired of hearing about all our favorite buzzwords like data, big data, et cetera, combining into something that those things we roughly understand, combining into something we don't understand, which has been termed the fourth industrial revolution, or if you're feeling really trendy, you can call it Industry 4.0, because people like to give names to things. And this is basically, if you can see this on the screen, I hope it's large enough. This is basically a kind of diagram of the last 200 years. These are the industrial revolutions, from the kind of the cottages and blacksmiths of the pre-industrial era to the mills of the Industrial Revolution, to Ford's assembly line of the second Industrial Revolution, to the computerization of that assembly line in offshore factories, often in Asia, of the third Industrial Revolution. And the fourth is this distributed model. And if that looks strange, then again, think of Airbnb. This has already happened in many of our sectors, in our service sectors. When it comes to housing, that's a kind of interesting thing, because and there's a kind of running joke in the world of buildings and housing, which is that prefabrication, manufacturing of housing, has been the future for as long as anybody can remember. It never seems to come about. And one of the reasons why it doesn't come about, and there's a lot of reasons, but one of the reasons why that shift, that transformation never comes, is because usually what they're talking about is the model on the left, the big centralized Fordist factory. Now, the problem with that model is it costs millions of pounds to set up a factory. And it can only produce one standard, one-size-fits-all product and then ship it. So it's quite successful for clothing and things like that, but it's not very successful for buildings, because buildings are not one-size-fits-all and they don't ship very well. So what tends to happen is that these factories go bust. And so what we began to see, I'll skip back, what we began to see was that the digital fabrication technology, like 3D printers and CNC machines, were plummeting in price. And so we began to realize that actually this model on the right could increasingly begin to match or even outperform the model on the left. Not necessarily in terms of efficiency, but in terms of effectiveness. And there's a really big difference between those two. So maybe the factory of the future that will be manufacturing our buildings will look a lot less like this and a lot more like this. So a kind of factory you can set up even in a workshop for a few €1,000s. And so then you can start to explore other things. So the other factor that you can bring to that is the web. And we began to realize this, that at the moment, when we design buildings, basically architects are reinventing the wheel every single time. They're redesigning every single building from scratch, which is really, really stupid. So you basically have underpaid interns sort of drawing these drawings, and down the road there's another underpaid intern doing the same drawing, right? And so suddenly we realized that the open source revolution, which had transformed software, was now going to transform hardware too. Because suddenly you can move into a world where an architect or an engineer only has to produce a solution to a problem once and share it, and it's solved for everybody forever. Because somebody else can then come and download that from the commons and use it for themselves. And if they make an improvement, they can contribute that back. So that was really the genesis. A few years ago, we started working on the WikiHouse project. And it was literally that. It was an experiment in applying this idea of, can you share design solutions as code, open source on the web, and allow any architect and engineer to improve it? So effectively, you could share designs online. You can download cutting files for a building, which looks something like this. You can download those. They go straight to a machine which looks something like this, which is called a CNC machine. On here it says about £11,000. In fact, I was recently speaking to a team in Norway who were trying to make one of these machines that you could buy for about 1,000 or 2,000 euros. It uses standard, in this case, we started with standard timber plywood because it's universally, or at least widely available, and it's the same. And what effectively it makes is the mother of all IKEA kits. Every single part is labeled. You don't have drawings because nobody knows how to read architectural drawings. Not even architects know how to read architectural drawings. you basically get an IKEA manual like this. And so this here is a video of a farmhouse that was built in the UK about a year and a half ago. And this video is actually taken over 2 or 3 days. And what's really, really interesting about this video is that there are no construction professionals in it. So this is a Japanese design principle called poka-yoke, or mistake proofing. So a bit like a plug socket. You can't get it wrong. You just have to slot it together. And again, this is how IKEA products already work. So the power of this is that a team with no construction skills can very, very quickly build a house to a very, very high level of precision and quality. And when you get the laser measure out at the end of it and you measure the deviation along the entire length of the house, the difference between the computer model and the real house is 7 millimeters. Now, that's the kind of precision that, you know, today you probably have to go to a German company to get that, you know. And this was built by a farmer. And it's not magic, that's just what digital fabrication can do. But the really interesting thing about this is that really the technology is not the point. Technology is just a Trojan horse. Because actually, this is really a Trojan horse for this. What you realize you're doing is you're building people's capacities, because over the course of doing the project, people have learned how to do it. Sometimes they've even set up their own local factory, and they then start setting up a small business to manufacture other things for people in their local community. So it's about building capacity. And the thing that I most love about this photograph is this photograph. I get invited to come and talk at innovation festivals because this is supposed to be innovative, right? But this is actually how we built homes and cities throughout most of history. We just forgot how to do it for a few hundred years. These are old, old economics. And lots of languages have a word for this. In the English, we call it barn raising. In Finnish, I think they call it talkut. I don't know if there's an equivalent word here in Latvia, but the idea of people building stuff together for themselves. And that's why it's no accident that the diagram, when you look at this diagram, that the fourth industrial revolution, in terms of its politics and its culture and its economics, it most resembles the pre-industrial age. I'll come back to that at the end. Of course, now, you know, so the point I always make there is that really the only difference between traditional vernaculars and open source is a web connection and digital tools. We can return to those models with these awesome world-class digital technologies in our hands. And of course, now that means we can do that thinking on a global scale. And so all we did is we just started this experiment and we put it online. And suddenly, before we knew it, teams of architects and engineers all over the world were taking this and using it and prototyping it and experimenting with it and building small structures with it and contributing back their improvements. And it's at the point now where, you know, there's quite a few pilot projects happening in various places around the world where people have been doing this. So this is a team in Christchurch in New Zealand, obviously following the failure of the centralized development model to respond to the earthquake there. This is one that sometimes we don't even know about them until after they've been made. Someone just tweets us a photo. This is one that's somewhere in the Austrian Alps. We've got no idea where. This is it being used to retrofit into existing buildings, to build internal walls inside existing buildings. I know about that one because it's my house. And so on and so on. And so this, by the way, is a photo of that farmhouse that I showed earlier as it looks today. And it's about kind of, it's very difficult to explain the power and the difference it is when we no longer when objects are no longer alien to us. In the open source hardware movement, they have a lovely phrase, which is, if you can't mend it, you don't own it. So there's an incredible power of changing our relationship with the space and the buildings around us, where we invest our time and our understanding into looking after them. So it's about building deeply resilient neighborhoods and deeply resilient places, which is a very, very stark contrast to these kind of top-down storage for humans kind of neighborhoods, which are produced by the speculative model, where really people don't even know their neighbor. They certainly don't start a business. This is the opposite of that, where the process of making the house is the process of making a community. It's the process of making an economy. And by the way, economically it works, because disintermediating the developers means that the same house on the same piece of land costs dramatically less. There's also an important fundamental point here, which is that all of us, I imagine, agree that our buildings need to consume less energy in the 21st century. I mean, Donald Trump's not here. So all of us agree that. And yet, the only people with a direct incentive to put more insulation in the walls are the people who are going to be paying the heating bills for the next 20 years. So if we're serious about building a more sustainable built environment, it has to be with the people who are going to live in the homes. It doesn't work to do it top down. And so immediately you then begin, well, how could this scale? Because plywood isn't available everywhere, right? Timber isn't available everywhere. I mean, luckily, here we are. I mean, we're basically in the timber capital of the world, aren't we, almost? But not every country has timber. But the basic diagram applies that the idea that what you can create is, instead of a big, centralized, globalized supply chain or manufacturing supply chain, you can make a local supply chain. All you need is the right combination of materials, machines, and small businesses. So actually, most of the machines that will do this haven't been invented yet. So that's an interesting question. So obviously, there's lots of people exploring different ways of doing this, from 3D printed concrete, which is an obvious one, but actually quite difficult, to large-scale cross-laminate timber buildings, which can do high density, to this, which is sort of kind of replicating traditional joinery. I think there's something quite interesting in plastics, the idea of reusing waste plastic streams for construction. This is a fascinating but really boring project, which is something called a mechanical ventilator with heat recovery. It saves lots and lots of energy. They usually cost about 200 euros. This is one that can be made on a 3D printer, and it costs about 20 euros to make. But the bit that we kind of got to that point, and we realized that the bit that we really need to build, if we want to connect up this distributed economy, this new distributed sector, we need to build the digital infrastructures underneath it. And that's what we've been working on. Because fundamentally, we have a problem in the design of our built environment too, which is that the knowledge to do it is in the heads of professionals. So, and they spend all day sharing information around and sending files to each other in inboxes. And digital fabrication doesn't affect this. Right? We all know this story of where, you know, you have a file in your, and there's a version 1, and there's version 2, and final version, final version. No really final version this time, right? We know this, right? So knowledge is a huge barrier in the whole process. So where we've got to with kind of digitizing buildings so far is we've just got to kind of sharing information in the cloud, and that's not good enough. Just sharing files. It's just like taking paper and making the digital version of it. It's not real transformation. What we need to do is move from sharing files, information, to sharing knowledge. And the way that we do that, this is something called parametric design. So this is where, here on the screen, you can see it, we've taken the example of the chair. You can take design knowledge and you can write it literally as code. So this is essentially an algorithm that knows the rules of a chair, and the output looks something like this. So you can change the variables, but the chair just instantly updates. And this is what we call a pattern. And the world around us is full of patterns. Pretty much everything from a chair to a microphone to a light to a road to a roundabout, they're all design patterns. And we're redrawing them every single time with knowledge that's in the head of professionals. So what we have is this power to automate this. The problem is it's all been offline proprietary software. So the thing that we're working on next is to make an open source web-based version of this, so that these robots, these bots, these patterns can live in the World Wide Web and they can speak to each other, which makes it's like hyperlinking. It's simple but exponentially powerful. So this is a concept that we call the pattern web. So it's the idea that we can take exponentially complex design problems and we can automate them, not in a Silicon Valley company like thousands of miles away, but distributed by everyone, that's open and neutral like the web. This idea also isn't new. A guy called Christopher Alexander did all the thinking, something called the pattern language. And what he pointed out was that really what we're talking about is a language that describes and defines our built environment. Hitherto, that language has always only been written and read by humans, but effectively what we're talking about is creating an open coding language for the built environment. And that will happen in the next few decades, we hope. And you can do cool things with that. So if that sounds really abstract and weird, don't worry, I'm going to stop being abstract and weird now. The application of that is much simpler, and it looks like this, if you can see this on the screen. Basically, it's a web-based program where you're designing, and it won't let you break the rules. So you're pushing and pulling the house, and it won't let you go wrong. But what it's doing is, in the background, the algorithms are writing every single detail, they're calculating every single screw, they could even be calculating the energy impact or the environmental impact of your building if you hook them up to a live data set. So all the things that you previously had to be locked behind, 100 professionals sucking their teeth and going, ooh, I'm not sure, we can get those things open and on the web. And it's incredibly powerful because you then go click, it gives you your cutting files. So we're prototyping that at the moment. The other thing that we realized is that it's not just these patterns, this automation isn't just for the design information of the built environment, it's also for the future of regulation. So this is actually an example we're doing where we're digitizing regulation, where we're taking the document on the left-hand side is a really, really boring long document, which is the planning regulations of a borough in London. And that you're meant to be able to understand. Of course, no one can understand it. It's incredibly hard work. So what we did is we took that and we turned it into a pattern. So we took it into machine-readable rules. That means that you can then plug that. So the app that I just showed you could also tell you whether you're compliant with the planning regulations as you design. So removing thousands of hours worth of bureaucracy, which of course is good for democracy, in the sense that it makes it more transparent. It's good for government because it saves governments loads of money. And it's also good for the market because market hates risk. We also believe this is going to transform fundamentally the way that we invest in our built environment, is because we can start to move from just valuing these dumb property assets to something really, really powerful, which is understanding that homes are the infrastructure and cities are the infrastructure of our daily lives. They have a huge impact on our health, on our well-being, on care, for example. And that's kind of hugely been ignored. So if you can use these digitization to essentially prove or demonstrate the impact of a design decision before you make it, suddenly our policies and our investment models can be based not on objects themselves, but on the outcomes of those objects. So it's a bit like moving from talking about schools to talking about education, from talking about hospitals to talking about health, or as Cedric Price put it, from the design of bridges to the design of how to get to the other side. So there's some really, really interesting potentials in this technology. Finally, I want to kind of finish by talking about the bigger industrial picture of what that means. Obviously, what we believe is that there is another housing economy out there. It's always been there under our nose. We can truly begin to envision a radically different way of building cities. Taking that long tail, the many small players, that is citizens, communities, small local businesses, and giving them the tools directly to build cities for themselves, and integrating things like solar energy. So the same story, is happening in the world of energy, from dependence on centralized power stations to having solar panels on your roof, etc. This is really good for local economies, and it also means that we can tackle the challenge of sustainable, affordable housing. But this is something that goes deep with us, right? The story of the 20th century was the story of centralized industrial production. And we didn't really appreciate the extent to which our political, cultural, and social norms were almost entirely shaped by that idea of centralized ownership of production. Almost everything about our lives was defined, and even our sense of identity was defined by this model, that you are a worker, you are a consumer, you are a borrower, you are a voter. what we're seeing around the world is that this model is failing. And the good news is that it doesn't need to be the model anymore, right? It's not the only game in the room. So I want to leave you with a kind of diagram that's actually more about politics or the political implications of this. Throughout the 20th century, the running assumption was that when it came to tackling big problems, there were only two industrial forces capable of doing it. That was the market or the state. And of course, the entirety of 20th century politics was defined by this argument, red versus blue. And of course, in the latter part of the 21st century, what we saw was the shrinking of the state and the growth of the private sector. Now, in the 1970s, we realized there was something missing from this diagram of the world, that it was much too simplistic, and that was, of course, the third sector, which is non-profits and NGOs, and they do awesome stuff too. But actually, there was something also missing that we still haven't fully realized. There was another sector that was there all along. In fact, it was there before a sector was a thing you were allowed to be, and that is the citizen sector. That is people doing stuff for themselves. And it turns out, actually, most care has always been done by the citizen sector. No government has enough money to provide care entirely through the state. We rely on people bringing up their own children, right? But we didn't have the tools before now to see that citizen sector as industrializable, as scalable. And that is the promise of digital technology, which is that for the first time, we can build platforms and tools to turn the citizen sector into a force rather than anything else. And part of that, by the way, is building the digital infrastructures. So one of the things I'd like to throw in here, startups won't solve this problem. This is not a private sector. Technology is not a private sector story. Digitization is like the whole of society transitioning from not having paper to having paper, but with more zeros on the end. This is a fundamental industrial revolution, and that whole diagram needs to move. But one of the things that is changing is our ability to change the way that we think of ourselves. You are not just a consumer. You are not just a borrower. You are not just a worker. You are first and foremost, and after the robots have come and replaced all our jobs, the last thing you will be is a citizen. That is a person who does something because the society around you needs you to do it. Whether that's your family or your friends or the village that you live in or the country that you live in or the continent that you live in. And of course, that is a vision that sadly a lot of Brits have lost sight of lately. Well, 52% of them. I want to finish with this quote by another of my heroes, Jane Jacobs, which basically sums up everything I've said in half an hour in about half a minute, or a few seconds, which is, cities can provide something for everyone, but only because and only when they are created by everyone. And that applies not just to cities, but to the big challenges that we face, like climate change, that can be so daunting, like reforming our political institutions. We can solve these big, deep, systemic problems, but we cannot do it if we continue to see people just as consumers, as a problem to be solved. We have to see them first and foremost as citizens and to dedicate ourselves to the question of using digital technology to give them the tools to be better citizens. Thank you very much indeed.